Welcome. In this video, I'll be constructing confidence intervals for a population mean, assuming the population standard deviation is known. A confidence interval constructed from sample data is a range of values that is likely to include the population parameter at some specified confidence level. The confidence interval for a population mean is determined by taking the sample mean, the point estimate, and subtracting and adding a margin of error to it. So, if the population standard deviation is known, the margin of error is determined by z a over 2 times alpha over sigma over root n, where a, the significance level, is 1 minus the confidence level, and correspondingly, the confidence level is 1 minus a. So if the confidence level is 95%, A will be 1 minus 0.95, which equals 0.5. Z confidence interval, ZA over 2 here is a single value called the critical value. It can be found in the normal tables or by using software. When constructing a 95% confidence interval, for example, the confidence level 0.95 is in the middle of the distribution, and the remaining 0.05 alpha is divided equally into the two tails as 0.025 each. From the less than cumulative standard normal tables, 0.025 in the left tail corresponds to a z-value of negative 1.96. And due to symmetry, it will be positive 1.96 for the right tail. So the z critical value corresponding to the 95% confidence level, which we write as z.025, is 1.96. Okay, we are now ready to create a confidence interval when we do not know the population standard deviation. And we are using the distribution notice. Here it says 50 doctors. I actually changed that to 40, so that's the only difference. So you're looking at a significance level of 0.05. If we're taking a confidence level of 95, the significance is 0.05. When we split that into two pieces for each tail, we get 0.025. The sample mean that we obtained from the sample was 145,580, and the sample standard deviation was 13,200. And the other things we want to write down, we know the sample size in this case is 40. Now we already answered this question. Do we use t-row or z-score? We determined we're using a t-value, and the reason why is the population standard deviation is unknown. Okay, the most common mistake that we make is that we see the word standard deviation and then we assume that we know the population standard deviation. We will always be given a standard deviation. What we have to determine is that standard deviation from the population or the sample. We won't be able to complete this problem if we didn't have a standard deviation. So again, we will always be given a standard deviation if it's the sample standard deviation. If it's a sample. Okay, standard deviation is the only one that we're given. Then we're going to have to use the t's. If we're given both, what do we know, the population standard deviation, then you're going to use that population standard deviation with z-scores. This is we can continue because it meets the requirement of a normal distributions. Or a sample size over 30. The sample size is 40, so we're good to continue. We're now ready to create our confidence interval, where we take our point estimate, which is our sample mean, and we're going to add and subtract the margin of error, reading out the formula for margin of error. It's going to look very similar. It's going to be the t-score with alpha over t alpha over 2 with a certain amount of degrees of freedom. We found this value, the t-score with alpha over 2, so 0.025 in its tail, each tail, and our degrees of freedom, we have 40 degrees of freedom, so in this case there are 39, and if you refer to your t-chart, our t chart, we got to 0.023 as the value we were looking. We can just plug into calculate the margin of error to 0.023. That is the t value. We need the sample standard deviation, which is 13,200, and the square root of n. We're not using degrees of freedom. We are using 40 degrees of freedom was only used in the t value. When you calculate that value, when you multiply that out to 0.023 times 13,200 divided by the square root of 40, what do we get? 4,222 and 21. So 4,222.21, that's the value we are going to add and subtract from our point estimate of 145,580. We're going to add and subtract this value. So when you subtract that value, so when you take 145,580 and you subtract 4,222.21, you get 141,357 and 79 cents. That's a dollar figure, and when you add that value, what do we get? 145,580 plus 4,222.21. You get $149,802.21. This is the lower bound and upper bound for our confidence interval. We will say it will be between here. If we wrote this as an inequality, this was our estimate to interpret this. We are 95% confident that the true population parameter, in this case the mean, the average salary of all doctors from public institutions, is contained between these two values of 140, 1,000, approximately up to approximately 149.8. So these are the lower bound and upper bound for our confidence interval. Quickly, I just want to summarize. Only difference between this and we calculate confidence intervals earlier in this module is that we don't know the population standard deviation. In that case, if we don't know that, we have to use the t distribution that requires us to look at the alpha over 2 just like before, and also look at this value of degrees of freedom using our t chart. We get a t value, and only other difference between other than that, the t value, is that we have the standard deviation here is the sample standard deviation and not the population standard deviation. Other than that, calculating the margin of error and adding that to our point estimate, and then in our TRPI, or rotational confidence interval, are all basically identical, plugging this information into StatCrunch. In StatCrunch, it's quite easy. We're still in the stat menu, just like when we were in looking at the proportion and z-stats, but now we're looking at t-stats. The t distributions, because we don't know the population standard deviation. We're looking at one sample with summary. That means with the summary, we're not looking at columns of A/B data. We have the sample mean. We have the sample standard deviation. In this case, our sample mean was 145,580, and if we look back to the sample standard deviation, that was 13,200. Our sample size in this case was 40. We're not doing a hypothesis test. We're looking at a confidence level, confidence interval with a 95% confidence level. Okay, let's hit compute, and we're going to get our interval 141,358.44 and 1. At 149,001.56. We're going to have a little bit of difference here. Notice their standard of error is the standard error. Excuse me, that's not the margin of error, but there are difference. There's going to be, because they're going to have more exact values. We're using around the t-score, t-value, right? In that case, we're going to get slightly different numbers. So that's the difference here. I don't mind if you use StatCrunch to check your work. You shall have a little bit of difference, but if you have a large difference, that will be something to post to the discussion forum, so we can get that clear away. Good thing we do have a discussion forum and Moodle. And that's all from me. Thank you.